Voyager 1, NASA's farthest voyaging rocket, continues its amazing venture through space, flawlessly communicating significant information from the deepest areas of the universe. For almost 50 years, this phenomenal space probe has revolutionized our understanding of space. However, as of late, the spacecraft has been communicating disturbing data back to Earth, leaving the entire space industry in shock. Since the beginning of recorded history, researchers have been enthralled by the secrets that lie beyond our heavenly boundaries. This interest prompted the historic launch of the Explorer 1 and Explorer 2 shuttles, among other remarkable space missions. These momentous missions, which had been discussed for quite some time, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5 of that same year, Explorer 1 followed suit. These twin probes, each weighing a significant 720 kilograms comparable to a small vehicle, were propelled into space during a rare alignment of the outer planets. Throughout their staggering odyssey, the courageous Voyagers navigated different directions and speeds, leading to a crucial moment on December 15, 1977, when Explorer 1 outpaced its identical twin due to variations in their paths. Since then, Explorer 1 has become a significant asset, providing us with a wealth of information and unraveling space-related secrets. Before we delve into Explorer 1's startling new discovery that stunned the entire space industry, let's explore the exceptional images captured by the rocket during its pivotal Jovian imaging mission in 1978. Explorer 1 was positioned roughly 265 million kilometers from Earth. From this vantage point, it communicated a stunning number of photos back to Earth. In January 1979, it embarked on an exceptional 100-hour endeavor, capturing a mesmerizing time-lapse film exhibiting 10 rotations of Jupiter. A cornucopia of 3,750 pictures allowed us to observe Jupiter's magnificent dance in vivid detail. In the ensuing months, Explorer 1 wandered through the Jovian moon system, making a striking revelation: the presence of a small ring surrounding Jupiter and 2 new moons, further expanding our understanding of Jupiter's fascinating domain. To ensure safe passage and prevent a potential impact with Titan, one of Saturn's moons, corrective maneuvers were executed. Explorer 1 continued its celestial journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the culmination of the Saturn mission, researchers decided to conclude the planetary phase, pushing both Explorer 1 and Explorer 2 beyond the bounds of our planetary group, leaping through space at an astonishing rate of 325 million kilometers per year. In January 1990, another chapter began: the Explorer interstellar mission. During this stage, Explorer 1 delivered some of the most famous photos in history, immortalizing the Sun and the majority of the planets. One person who played a vital role in extending the missions beyond their initial objectives was the prominent astronomer Dr. Vasily Sands. As part of the Explorer mission's imaging team, Dr. Sands ardently advocated for capturing one final set of pictures as a goodbye gift to humanity. Against all odds, his steadfast determination bore fruit on February 14, 1990, when Explorer 1, positioned 6 billion kilometers from the Sun, embarked on a visual excursion well known as the planetary family portrait. These stunning images, totaling 60, added to the shuttle's remarkable collection of 670 photos. During its encounter with Neptune, Voyager 2 achieved an extraordinary accomplishment by recording wind speeds exceeding 13,100 meters per second, the fastest wind ever documented within our local planetary group. As the rocket ventured within 280 miles of Neptune's blue, methane-rich atmosphere, it provided remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest residents within our planetary group, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's peculiar features, such as its nitrogen gas-spewing ice volcanoes, which pushed icy particles 5 miles into its nebulous atmosphere, also captivated our imagination. These exceptional discoveries expanded our comprehension of the vast variety and complexity of celestial objects residing in the farthest reaches of our solar system. The accomplishments of the Explorer twin tests have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these remote worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Explorer 2, in particular, achieved several exceptional feats during its journey. It made history in 1986 by becoming the first shuttle to fly by Uranus. Just 3 years later, it achieved another remarkable feat with a flyby of Neptune. To this day, it remains the only spacecraft to have ventured on such a path. As the Explorer rockets continued their journey, NASA implemented various measures to extend their operational lifespan. Over recent years, unnecessary parts and heaters have been deactivated to conserve energy, ensuring that these courageous explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this remarkable project from the beginning, the culmination of the Explorer missions is both a moment of pride and a tinge of melancholy. Their steadfast dedication and passionate efforts have far surpassed initial expectations. The wealth of data returned by the explorers has provided valuable insights, fueled countless discoveries, and ignited the imagination of scientists and space enthusiasts alike. Explorer 1 and Explorer 2 were no ordinary space probes. They were meticulously designed as stable platforms, with a rotation rate over 15 times slower than the hour hand of a clock. This design minimized visual blurring as the spacecraft captured images and data while journeying through the infinity of space. Even before their encounters with the outer planets, their impressive imaging abilities began to astonish scientists and the public alike. The spacecraft began transmitting images of Jupiter before reaching the gas giant. These early images displaying the swirling clouds and the iconic Great Red Spot delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments identified peculiar signals from Io, which were confirmed by the distinctive images they captured. Towering volcanic plumes and a surface scarred by eruptions were revealed. One of Io's most prominent volcanoes erupted with a force 10 times greater than Mount St. Helens, covering an area almost the size of France. Before their journey into interstellar space, the spacecraft's cameras were ultimately shut down to conserve power and memory. It is noteworthy that the photographs they captured did not include Mercury and Mars, for various reasons. Aside from the Explorer 1 and 2 interstellar probes, NASA has also operated other prominent spacecraft like Voyager 10, Voyager 11, and New Horizons. Explorer 1 passed by Voyager 10 on February 17, 1998, marking the moment when Voyager 10 became the most distant spacecraft. Explorer 1 continued its solitary journey for an additional 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to witness this, NASA didn't publicly announce the achievement until 2013. These maneuvers played an essential role in propelling Explorer 1 and 2 on their audacious mission to explore the outer reaches of our solar system. The spacecraft needed more than just their propulsion systems, they needed a boost. Gravity assists provided just that. Imagine the two fearless rockets, Voyager 1 and Voyager 2, embarking on their grand tour. Instead of relying solely on their motors, they engaged in a celestial dance with planetary giants. Leveraging the vast gravitational pull of these giants, they slingshot themselves onward, conserving fuel and gaining speed. Performing a gravity assist requires exceptional precision. If Explorer 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation. Fortunately, the brilliant minds behind these missions executed the maneuvers with incredible accuracy. Another key to success was the Deep Space Network, DSN, often called the Interstellar Phone Line. The DSN is a system of massive radio antennas located in California, Spain, and Australia. These antennas, ranging from 26 to 70 meters in diameter, acted as amplifiers to communicate with the spacecraft. The DSN not only receives faint signals traveling billions of miles at the speed of light, but also sends vital commands to guide and update the spacecraft. It's a tireless, 24/7 operation that ensures we stay connected to our space probes, even in the farthest reaches of space.